In 1885, Chicago faced land prices tripled by disaster, where 10-story stone walls had become a dead end for architects. Yet without cranes, electricity, or modern machinery, a small team set out to build higher than anyone dared, using steel, sweat, and sheer nerve. What actually happened on those muddy streets? And why did this single building forever change every city's skyline? The answer begins with the ruins of a burnt city and one radical idea. In the aftermath of the Great Fire of 1871, Chicago's downtown was a blackened grid of ashes and twisted iron. More than 17,500 buildings had vanished in less than 2 days, wiping out 3.3 square miles at the city's heart. What the flames left behind was a rare kind of opportunity, empty land at the very center of America's fastest-growing metropolis. Within months, speculators and investors crowded into the burn zone, snapping up lots at prices no one could have imagined before the fire. Property values soared as families and businesses, desperate to rebuild, competed for every square foot. Some lots tripled in value within a decade. The city's population, barely 300,000 at the time of the fire, would reach 1 million by 1891, packing more and more people and commerce into the same small footprint. For property owners, the numbers were impossible to ignore. A single block could be worth more than the buildings that stood on it. Landlords and developers realized that the only way to justify these soaring prices was to squeeze more rentable space onto each plot. But there was a catch. Traditional masonry construction hit a hard ceiling at about 10 stories. Beyond that, brick and stone walls needed to be so thick at the base, sometimes 6 feet or more, that usable floor space shrank and construction costs exploded. The city's new fire codes, meant to prevent another disaster, banned cheap wooden buildings and demanded expensive fireproof materials. That only pushed prices higher. By the early 1880s, downtown Chicago had become a real estate pressure cooker. Every delay in rebuilding meant lost rent. Every extra floor above the street brought in more tenants, more offices, more revenue. But the old ways of building simply could not keep up with the city's ambitions or its economics. Architects and engineers faced a stark choice: find a way to build higher without making walls thicker, or accept that the city's vertical dreams would be strangled by their own weight. Investors, many from out of state, poured capital into the city, betting that Chicago would not just recover, but leap ahead of every rival. The Home Insurance Company of New York, looking for a bold statement, commissioned William LeBaron Jenney to design a new office tower on the corner of LaSalle and Adams. The commission was clear: create a building that could rise above its neighbors, maximize every inch of rentable space, and stand as proof that Chicago was ready for a new kind of future. In the race to fill the sky, the rules of real estate had changed. Only the most daring solutions would pay off. At the northeast corner of LaSalle and Adams, a new kind of building began to take shape in the spring of 1884. The Home Insurance Company of New York had chosen this spot for its Midwest headquarters, determined to make a statement that would stand out in Chicago's rising skyline. Their brief was ambitious: create an office tower that could climb higher than any around it, offer more rental space per square foot, and prove fireproof in a city still haunted by memories of disaster. William LeBaron Jenney was the architect they trusted with the challenge. He was a civil engineer by training, with experience in bridges and ironwork, fields that demanded new ways of thinking about weight, strength, and support. Jenney saw the limits of traditional masonry firsthand. He knew that as buildings grew taller, the walls at ground level had to be so thick they swallowed up valuable space and made upper floors nearly impossible. The solution, he believed, lay not in stacking more brick, but in changing the very bones of the building. Instead of relying on solid stone or brick to carry every ounce of weight, Jenney proposed something radical: a skeleton of iron and steel that would bear the load. The floors and walls would hang from this frame, much like flesh on a body, instead of pressing down on each other in a solid block. This approach would allow for thinner walls, larger windows, and more usable floor space from basement to roof. It would also mean the building could rise higher without crushing itself, an idea that seemed almost reckless to some of his peers. The home insurance building was commissioned in the fall of 1883, and by early 1884, Jenny's plans were ready. The address, 135 South LaSalle, would soon become known throughout the city. The design called for 10 stories, reaching 138 feet, with the possibility of expansion. The structure would be built around a grid of iron columns and steel beams, bolted and riveted together into a rigid frame. Brick and terracotta would wrap the skeleton, not to hold it up, but to keep out wind and rain. Jenny's vision was more than a technical gamble. It was a direct response to the economic and physical pressures of Chicago's downtown. Developers needed rentable space, not wasted masonry. Tenants wanted light-filled offices, not dim rooms behind fortress-like walls. The home insurance company wanted a building that would outlast fire, attract business, and justify its investment in one of the most expensive corners in the country. As word spread of Jenny's plan, the project drew attention from architects, engineers, and skeptics alike. Some doubted that such a lightweight frame could stand up to the city's infamous winds, let alone the daily pounding of street traffic and the weight of hundreds of workers. City officials paused construction at one point, worried the building might collapse under its own daring. But Jenny's calculations held. The home insurance building would soon rise as a prototype for a new era in architecture, a structure that did not just fill the sky, but redefined what a building could be. Steel for the home insurance building began its journey hundreds of miles from Chicago, forged in the roaring Bessemer Mills of Pennsylvania. Massive I-beams, each weighing 900 pounds, were loaded onto rail cars and sent west. The train ride ended in the city's sprawling rail yards, but the hardest part was still ahead. Horse-drawn wagons, creaking under the weight, hauled these beams through muddy, crowded streets, dodging cable cars and market carts, inching their way to the construction site at LaSalle and Adams. Teamsters and laborers worked from dawn to dusk, unloading steel with nothing but grit, crowbars, and teamwork. But even the strongest beams would be useless if the ground could not hold them. Chicago's soil was a patchwork of clay and sand, soft and unpredictable. Builders faced a puzzle: how to support a 10-story building on Earth that could barely hold a barn. The answer came from bridge engineering. Crews drove long timber pilings deep into the muck, sometimes 30 or 40 feet down, until they hit firmer layers. On top of this forest of buried wood, workers poured a thick slab of concrete, a floating raft. This foundation did not anchor the building like a stone pier. Instead, it spread the weight out, acting like a snowshoe on deep powder, keeping the entire structure from sinking or tilting. The work was slow and relentless. Men swung sledgehammers to drive the pilings, their arms aching as each log vanished into the mud. Others mixed concrete by hand, shoveling sand and lime under the open sky. Every step was measured and checked, because a single mistake could crack the foundation or send the building off balance. When the raft finally set, the site was ready for the steel skeleton to rise. The beams, once just cargo from faraway mills, now waited in neat stacks, heavy, cold, and silent, ready to be lifted, one by one, into the sky. Timber derricks towered above the muddy streets, their heavy arms swinging with each new lift. These giant tripods, built from thick pine poles and anchored with hemp ropes, formed the backbone of every upward push. At ground level, a steam donkey engine wheezed and hissed, its iron drum winding rope through a maze of pulleys. The engine's steady chug sent cables skyward, hoisting steel beams that weighed up to 5 tons each. With no electric motors and no modern cranes, every inch of progress depended on this blend of muscle, rope, and steam. The riggers worked high above the city, balancing on narrow I-beams with nothing but their boots and nerve. They used hand signals to talk to the men below. One arm raised meant lift. A sharp wave meant stop. Every beam had to be swung into place with precision, guided by ropes and steady hands. A single slip could send a load crashing down or leave a worker dangling above the street. The tackle blocks, arranged for maximum advantage, multiplied the force of the donkey engine, but the real power came from the coordination of men who trusted each other with their lives. Once a beam reached its perch, the riveting gangs took over. 4 men formed the core of each team: the heater, the catcher, the bucker-up, and the riveter. Down below, the heater stood beside a glowing forge, pulling red-hot rivets from the flames. With a practiced flick, he tossed each rivet up to the catcher perched on the frame above. The catcher snatched the glowing metal from the air and shoved it into a waiting hole, where 2 steel plates met. On the far side, the bucker-up braced a heavy dolly against the factory head, while the riveter swung a sledgehammer, flattening the hot end with a series of rapid blows. Each strike had to land before the rivet cooled and shrank, locking the joint tight. The process repeated again and again, hundreds of times a day, each rivet cooling with a hiss and binding the skeleton into a single rigid body. The skeleton grew taller with every shift, beams and columns locked together by the heat and force of human hands. At the end of each day, the frame stood a little higher, held together by thousands of rivets, each one set in place before the city's first electric lights ever flickered on. The only thing keeping the building aloft was this relentless choreography of steam, rope, and sweat. The new steel skeleton changed more than just the way buildings stood. It transformed how they looked and how people lived and worked inside. Instead of thick stone walls pressed tight against the frame, masons built a thin shell of brick and terracotta, 1 floor at a time. These walls did not hold up the weight. They simply hung from steel supports, as light and flexible as the frame allowed. The curtain wall let in more daylight and opened the way for larger windows, giving tenants a view of the city that had never been possible from behind fortress-like masonry. But for the men who built it, the curtain wall offered little comfort. Workers balanced on planks barely wider than their boots, suspended 100 feet above the street. The only thing between them and the ground was a lattice of beams and the steady hands of their crew. There were no harnesses, no nets. Gusts off Lake Michigan could lift a hat from a head or send a board spinning into the void. Every step was a calculation. 1 foot on solid steel, the other searching for a plank that might shift under weight. Masons hoisted bricks and buckets of mortar by hand, passing them along makeshift walkways lashed to the rising frame. Each new row of brick was tied back to the steel, anchored with iron straps so the wall would hang true and not peel away in the wind. Communication on site was a language of necessity. Foremen used whistles and hand signals to coordinate the chaos. 1 sharp blast meant clear the way. 2 meant a load was coming up. 3 sent everyone scrambling for safety. Mistimed signals could leave a worker stranded on a ledge, or worse, caught beneath a swinging beam. With dozens of trades working side by side, ironworkers, masons, carpenters, there was no room for error. Every man depended on the rhythm of the crew and the trust built over long days and longer nights. Life on the skeleton was a test of nerve and balance. The city's future hung on the same thin beams as the men who built it, each day a wager between progress and survival. As the curtain walls closed around the frame, the building's true shape emerged, not just as a feat of engineering, but as a record of the risks taken by every hand that set brick to steel. Every sunrise brought a wave of urgency to the home insurance building site. Developers counted the cost of every hour, knowing that the money borrowed to fund construction came with steep interest. Each day that passed without a finished building meant thousands of dollars lost, money spent on loans, wages, and idle materials, all without a single cent in rent collected. The pressure mounted as autumn crept in. Chicago's winters were unforgiving. If the steel frame was not enclosed before the first hard freeze, mortar for the brick walls would refuse to set, turning to powder instead of stone. Exposed beams could contract in the cold, warping the skeleton and threatening the precise joins that held the whole structure together. Foremen pushed their crews harder, shouting over the wind, timing deliveries and lifts down to the minute. The risk was not just financial. A frozen work site stalled progress for months, driving up costs and drawing the ire of investors far from the muddy streets. The only defense was speed, closing in the floors before the weather turned, racing the calendar as much as the competition. For the men on the ground, every lost day was another reminder that the real enemy was not just gravity or height, but time itself. The home insurance building rose from foundation to roof in just 18 months. It was a pace that stunned both skeptics and competitors. Traditional masonry buildings of similar height often dragged on for 2 or even 3 years, slowed by the need to stack and cure endless tons of stone. This new steel skeleton, assembled beam by beam and locked tight with thousands of hand-driven rivets, proved that speed and strength could go hand in hand. 10 stories of rentable space now stood where only squat, thick-walled offices had been possible before. Engineers across the country took notice. Jenny's design became a touchstone, cited in journals and classrooms as proof that the old limits no longer applied. When the building was dismantled in 1931, it had already inspired a generation of towers in Chicago and beyond. No longer did architects have to wonder how high a building could go. The answer was simple. The only limit was the courage to build it. The workers who braved the heights and the engineers who trusted their math together sparked a skyline that keeps climbing, their achievement standing tall even after the original beams came down. Chicago's first skyscrapers rose without modern machines, but their impact towers over us still. Every steel and glass skyline traces its lineage to those hand-driven rivets and daring laborers. Today, as cities race upward and technology accelerates, the challenge remains unchanged. How far can human ingenuity reach when necessity demands it? The answer still shapes the world above our heads. Share your thoughts below.